Hey guys, welcome to Math with Miss Grundy. Sorry that this post is up so late. However, because I am so good at rate and unit rate, I was able to save money on things like toilet paper and laundry detergent, things that come in a quantity greater than one, because I was able to find the unit rate and the rate and figure out the best deal. So I was able to save some money and went to Gunther's and got some ice cream. If you're watching this video tomorrow, ask me what kind of ice cream I bought, or take a wild guess, and tomorrow let me know what your guess is. What kind of ice cream do you think that I get from Gunther's? So today we're going to be talking about proportional versus non-proportional situations. How do you know if a situation is proportional versus how do you know if it's non-proportional? And specifically, we're going to be looking at tables. So I want to go ahead and start and look at this first example. So this first example is me working some hours and me getting paid for my work. So before I even start, I'm going to find the constant of proportionality, which means how do I move from my x, remembering x is on the left, y is on the right. So how do I move from my x to my y? Remembering that I must use multiplication. So in order to figure out how do we move from our x, hours worked, to our pay, we're going to use this formula right here, where we put our y over x. And as I'm looking at my table, I notice something. And the first thing that I notice, or what I notice, is that this right here is the only ordered pair. Because remember, in a table, these are ordered pairs, and therefore we could graph them if we wanted. In fact, tomorrow we're starting to graph and look at graphs to identify proportional and non-proportional situations. Have no fear though, I will help you and you will be amazing at it. So I notice this is my only set of ordered pairs, 1, 8. So I'm going to go ahead and take this one set that was given to me and plug it in for k. Remembering my y goes over my x. So my k is going to be 8 over 1. And earlier today, we talked about how you could leave things in fraction form. However, they should be simplified down to the lowest equivalent ratio that you can get it to, or fraction. So someone asked me, could they leave 8 over 1? You could, but there's no real reason to, because 8 over 1, or 8 divided by 1, is 8. So that means that I move from my x to my y, multiplying by a constant of proportionality of 8. So that means every time I move from my x to my y, I multiply by 8, which is my constant. So 2 times my constant is 16, meaning in 2 hours, I will get paid a total of $16. Moving from my x to my y, multiplying by my constant. So that means in 3 hours, I will get paid $24. In 4 hours, times my constant, will let me know that I get paid $32. Alright, so we see the fraction in the 4.5. That just means 4.5 hours. If it's hard for you to work with fractions, we can go ahead and take and turn this into a decimal. So 4.5, or 4 5/10, times my constant is 36. There are multiple ways to know that this is 36 besides doing 42 times 8. Instead, I can do 4 times 8. And then I can say I have a half left, and half of 8 is 4. So 32, which is 4 times 8, plus half of 8, which is 4, is 36. If you want that broken down for you more, ask me in the morning. I would be more than happy to help you break that down. So in 5 hours, I will get $40. In 6 hours, I will get 48. In 6.5, remember in 6 hours I get 48. In a half hour, or half of my constant, 8, I get 4. So 48 plus 4 is 52. Again, if breaking it up like that doesn't quite make sense to you as 6 and then 0.5 and then individually multiplying them by 8, then that's fine. You can just off to the side, 6.5 times 8 and multiply. So looking at this situation, it is proportional because every single time I move from my x to my y, I have a constant of proportionality of 8. Remembering that the constant of proportionality can also help you find missing values. So if I made $96 and I wanted to figure out how many hours I would have to work to get $96, this means I'm now moving from my y to my x, which means that I'm moving in the opposite direction. Remember, before we were going from our x to our y. Now we're going from our y to our x. So we're moving in the opposite direction, which means that we have to take our constant and do the opposite or the inverse operation. The inverse of multiplication is division. So I'm going to take 96 divided by 8. And 96 divided by 8 is 12. So in 12 hours, I will make $96. Again, it's still proportional because when I move from my x to my y now, I multiply by 8, which was my constant every single time. So this is a proportional situation. I know because it has a constant of proportionality. The constant of proportionality is 8. How I found the constant of proportionality was I took my y value and then I took its corresponding, meaning the x value that goes with the y value, and plugged it underneath. So I got 8 over 1, which simplifies down to 8, which is the constant. Therefore, for every single hour I work, I will make $8 no matter what. And that is why this situation is proportional. And what I just said is my explanation as well as my push, as well as using the units. I talked about the hours. I talked about how much I would get paid. I talked about what the constant was. I talked about how I got the constant, the formula for the constant. That is how you should be explaining how a situation is proportional. Alright, so let's go ahead and take a look at our next one. So we have similar scenarios. We have our hours worked, which is our independent And we have our pay, which is our dependent. I know this for two different ways. First, how the table is set up. Secondly, because my pay is dependent on my number of hours. You could also say my number of hours change the amount that I'm getting paid. Alright, so the first thing we need to do is find our constant. So we are taking an ordered pair and we are putting our y over our x. We're putting our y over our x. Because again, we're moving from our x to our y. That is what our constant of proportionality tells us. Alright, so I have a y of 10 and an x of 1. Again, I'm going to simplify it down, which means my constant of proportionality is 10. And now I'm going to go make sure 1 times my constant, aka 10, is 10. 2 times my constant is 20. So this does not fit with this. Another way to think about it is if I were to set these up as ratios of 10 over 1 and set it equal to 18 over 2 and try to scale up, could I do it? The answer is no. Therefore, these are not equivalent ratios. Therefore, this situation is not proportional. So a couple of things could be happening in a non-proportional situation. First, this person may have struck a deal with their boss. Their boss may have called them and said, hey, I really need you to come in, so I'll pay you $2 extra for coming in. I know, it doesn't sound like a lot, but hey, if you need $2 extra, you need $2 extra. So potentially they started out with $2 extra, and then it just continued. Next year, you'll work on writing an equation for this scenario. All that you need to know for right now is that this situation is non-proportional. I know it is non-proportional because there is not a constant, there is not a constant of proportionality. And I know because when I set up 2 of my ordered pairs as a ratio, they are not equivalent. Therefore, I cannot always move from x, my hours worked, to my pay, my y. Alright, one last scenario. And this is one that we kind of we have seen before and we struggled a little bit. So, the first thing I'm going to do is find my constant of proportionality. So put my y over my x. Alright, so again, x and y. So I'm going to go ahead and put my y over my x, so 5 over 6. 5/6 is a fraction less than 1. And a fraction less than 1, all that it tells you is that when you move from the x to the y value should be smaller than the x value. Because anything times a fraction gives you anything times a fraction smaller than 1 gives you a smaller value than you originally started with. So I'm going to go ahead and write my constant of proportionality, and then I'm going to go ahead and check to make sure that this is correct. So I'm doing 12 times 5 over 6. And before you're like, can I turn this into a decimal? Fractions are something that just takes practice. The more you practice, the better you feel about fractions. In fact, I would much rather multiply by a fraction than multiply by a decimal. I think it's less work, and I think it's less brain power. So remember, any whole number has a denominator of 1. Before I multiply across, you could also do this after, but before I multiply across, I'm going to cross simplify. So I'm going to look at my 1 and my 6 because they are diagonal or kitty corner. And I know that 6 and 12 have a factor of 6. 12 divided by 6 is 2. 6 divided by 6 is 1. And then I'm going to multiply across. So 2 times 5 is 10. And 1 times 1 is 1. And that simplified is 10. So it's working so far. Let's go ahead and add another random number of boys in the class. Let's say there are 15. And now we have to find our missing value by multiplying by the constant. So 15 times 5 over 6. Place my 1 under my whole number. I cannot cross simplify. I can cross simplify. My bad. 3 goes into both 15 and 6. So 15 divided by 3 is 5. 6 divided by 3 is 2. Again, if I would not have caught that I could cross simplify, it's okay. I would have just done it at the end. So 5 times 5 is 25. 1 times 2 is 2. And then I'm going to simplify this as much as I can. 2 goes into 25 12 times with 1/2. So if there are 15 boys, according to our constant of proportionality, there would be 12.5 girls, which obviously is not possible. However, that is what my constant tells me. My constant of proportionality tells me. So if there were, this is the amount of girls. So there probably would not be 15 boys and 12.5 girls. But the situation is proportional. The reason why it is proportional is because it has a constant of proportionality of 5/6. The way I know is because I took one ordered pair and I plugged them into my constant of proportionality formula, y over x. And I got 5 over 6. I also know that every time I move from the boys to the girls, the amount of girls is 5/6 the amount of boys. Therefore, this situation is proportional. If you have any questions, drop a comment below. Share video, let your friends and classmates know that it's up, just in case they also need it. Please make sure that you are letting me know in class if there are other videos that you want me to make. Some of us were talking about struggling with maybe some decimal division. If you want a small tutorial video over that, please let me know. You can also leave a comment below. Click like, subscribe. I forget what else I'm supposed to say, but I'm sure you guys will fill me in tomorrow. I look forward to seeing you tomorrow, where we will be looking at graphs and determining if they are proportional or not. We'll also be doing the same thing on Friday, and then come Monday will be a review day over proportional and non-proportional situations via a table and graphs. And it will be a time for us to work on things that we might be struggling with. Have a great evening. I'm going to go enjoy my ice cream. Bye.